after the 8 to 10 years of use, they still should have something like 70 to 80% capacity left in them. So basically you're wasting them if you are destroying them and recycling them. So that's the main reason. Another one is you're reducing waste, and if it's not repurposed, then something needs to happen to it. So if it's not recycled either, then it will have to go to landfill, and also has a lot of capacity and energy left in it, so it can be a big hazard as well. Then there is the energy efficiency issue. To actually make a battery, it takes a lot of energy. So to repurpose a battery, you don't have to go through that cycle again. So you're not wasting that energy or using that energy. And then there's a cost saving. An EV battery that still has 70 to 80% life left in it is obviously a lot cheaper than a brand new battery, but it fills a very good need. Once it's repurposed, it can still work for a long time. If you don't have to recycle a battery, then you don't have to use a lot of energy because the battery is already there. And if you can prolong the life of that battery, you're not using any energy, and therefore you're using the energy once, and that will take you for a long time before you need to spend any more energy to create a battery or recycle it. Then there is a landfill avoidance. Why throw batteries away that are actually useful and can work for another 5 to 10 years in some of the applications. Then there's a circular economy. So again, by prolonging the life of a battery, you don't have to make new batteries. That gives you a lot of cost saving, and you can sustain the effort that you put into producing a battery for quite a few years. To actually make any of those metals, a lot of effort has to go from mining to refining and so on before you get lithium or cobalt or manganese or any of those elements. So if you don't have to make new ones, obviously you have retained your resources that once have already gone through all of this effort to make a battery. The biggest thing is cost saving. If you can buy a battery for a fraction of the price of a brand new battery and make an application for it, obviously you've saved a lot of money. That battery can be used for home energy storage. It can be used for AC and DC UPS. It can be used for microgrid and standalone power systems. But the battery component of it is a lot less expensive than it would have been if it was brand new. Then once you've done that, if you can assess the batteries and make the second life, that process creates a lot of jobs, a lot of knowledge. It's not a simple thing to do. And that means you created a lot of techniques to do that, and that by itself, because it creates value, it creates jobs too. Then there is a question of new markets. You could use these batteries, for example, in a remote EV charging stations where you can use renewable energy like solar and wind to directly charge these batteries, and these batteries would then charge the EV. Of course, doing that will create another revenue stream for companies that do the repurposing. You are buying the batteries at much lower price, and my own preference is really not to do very much other than assess them for a particular application, is not to do very much with them and just use them as they are inside another application. There is scalability, so it's very scalable. There is a lot of need for home energy storage, standalone power system, EV charging. So, for example, from here to Newman in Western Australia, right, 1,600 kilometers. There's hardly any place we can put an EV charging station. But if you can put batteries in there and connect them to solar and maybe wind and directly charge those batteries, you don't even need inverters. You just go directly to DC. This DC is then available to through DC to DC converter and battery charging control to charge EV. So you could have charging stations going all the way to Newman. Grid stability is another application. There is a lot of renewable energy available during the day, maybe at night, but it's intermittent. So if you can use that to store the available energy and then use that to stabilize the grid, then not only have you got excess energy, but you've got a stabilized grid as well. There is so many batteries that will be available. At the moment, there is something like 180,000 to maybe 250,000 EVs that are on Australian roads. Soon there will be a lot of EV batteries available, and repurposed batteries can then go into many applications, and then you can scale up the energy transition to the regional area by using these repurposed batteries. Yes, of course. As I said, these batteries still have 70 to 80% capacity, and as long as the state of health and state of safety is assured, and then they can go into many applications that involve solar and wind, and those will then start reducing the reliance on grid and more renewable energy. It will reduce the cost because the batteries will be lower cost, and therefore the energy storage will be lower cost. There is a decentralized, you can decentralize the whole energy system. That means standalone power systems can be used. Standalone power systems can then link up together and make a whole network of microgrids connected together. So the resilience of grid is much better. Of course, there is an environmental benefit to that, because now you're using renewable energy. You're using more and more of the renewable energy, sometimes 100% renewable energy. And the more there is batteries, the less dependence on diesel, for example. It doesn't have to come on and support the load. And the biggest thing is the local manufacturing. You know, for a company like us, it will create a lot of jobs making repurposed batteries. We are already employing a lot of engineers and researchers and apprentices, and there'll be more and more of those. As batteries become available, we can turn them into different applications, and that's another revenue stream for us, and lots of jobs for apprentices and engineers and researchers and every other job.